Last week we talked about engineering drawing, what engineering drawing is, and we tried to establish the fact that it's a professional language of the engineering, of the engineers. Sorry, and every field has their own language. Engineering field has its own language as so. So, and it's a graphic representation of what is about to happen. And we talked about that engineering drawing designs, and we also talked about dimensioning in engineering drawing. We talked about dimensioning in engineering drawing. Don't worry, I will ask them the admin to send this material so that we can go into it. So we talked about engineering drawing, and I made that sorry and dimensioning. I made us understood that there are different lines when it comes to engineering drawing, different types of pencils. We looked at that, and today let's quickly dive into assembly drawing. Assembly drawing. When you talk about engineering drawing and you don't bring in assembly drawing, it's not complete. So let's just see how we can go with this. Assembly drawing is a design document containing a full representation of a particular machine or units and all the data needed for its assembly and production. I repeat, I said assembly drawing is a design document containing a full representation of a particular machine or unit. Of a particular machine or unit. That's assembly drawing for you. Now, assembly drawing shows various parts of a machine in their proper working position. Assembly drawing shows various parts of a machine in their proper working positions in relative to each other. So they bring assembly drawing show the different working parts of a machine in relative to each other, how they work with each other, different drawings. That is what assembly drawing does. That is what assembly drawing does. Hello, Mr. Yomi. So, like what we say in engineering, and please just be patient for us. Let's get the materials available to you now. What's the PDF? What's this? Something else. I don't know how this is connected to you. Okay.
Please, let's be patient with the lecture. Engineering drawing is not what you can learn in abstract. Please, we need to display the material for you to understand better. Thank you.
This PDF first. Let me attach the PDF. Okay, this one. I think I've sent it. Mr. Yomi, please check the email.
All right.
Check the email, please. Let me know if you've gotten it.
I still don't have it.
I've I've sent it. Just refresh. JPTS
I've done
coordinators
that.
at yahoo.com. It's
Gmail.
coming.
It's Gmail,
You
not
gave me
Yahoo.
Yahoo.
I
Oh
gave you
shit!
Gmail,
You
not
gave me
Yahoo.
Yahoo. No, I saw
Check.
Yahoo here. Let me forward it.
Yeah.
Okay, let me go. Okay.
I gave you Gmail. Oh.
That's not it. Need PDF. Oh, that's not it. Mr. Yomi, check.
All right.
Check the Gmail now. Yeah, check your email.
I still don't have it.
What? Refresh, please. I sent the JPTS coordinators at gmail.com.
Coordinators with a double O, right?
Yes.
I've not received it anyway. Hello? Yeah, I can hear you.
I understand. What kind of network is this? This is what I want.
Just send me your what's it called? Just find me on WhatsApp on this line.
Let me check it.
Hello, students. We are so sorry. Please be patient. Please be patient.
Mr. Yomi, I just sent it again.
Hello, it's still not delivered to my mail. Please, can you send the
JP,
PowerPoint instead of converting it to PDF?
okay, to that mate, ba?
Just send
Okay,
it to WhatsApp. It's faster. Just send the PowerPoint. I will get it. Send it to WhatsApp.
the PowerPoint.
Yes,
That
yes.
was what I sent to you before that you couldn't open.
But you said it was PDF now.
No, it was PowerPoint. This last one
It's
is
not open.
PDF. What the fuck is going on
I'm
here?
not getting anything now.
Okay, let me do something. This email. This email. It's PDF. Send PDF. Are you converting it? No, I'm not. Send it to PDF. It's PDF I sent to you. Mr. Yemi, check the email again. Check the email.
All right, all right, all right.
Check the email. Then I'm
Okay.
forwarding something to your WhatsApp to check whichever. Check the email, check the WhatsApp. Mr. Yomi, Mr. Yomi, Mr. Yomi. Okay.
All right. Just okay.
Have you
I'm with you.
gotten
I'm
it?
with
Is it on your email, is on your
you.
WhatsApp, so
Okay.
do
I think
something
I
now.
have it now.
Okay, please let me see the slide, please. Just help me go to slide 7. Let's be on slide 7. Go to slide 7. I'll start from there. That's our topic for today.
Yeah, yeah. I think I have it now. I'm downloading it. Continue.
Okay, it's on your WhatsApp. Go to slide 7. That's where I am now. So let me
Continue. I'm
start from
downloading
there.
it already.
All right. Sorry everyone for the delay. Let's quickly go on what we have here today. And like as I was saying, we've done a little recap of what we did the previous um, lecture. And I'm saying today we're looking at assembly drawing. Like the assembly engineering drawing is not complete without an assembly drawing. And I said assembly drawing is a design document containing a full representation of a particular machine or unit and all the data needed for its assembly and production. It is a design document containing a full representation of a particular machine or unit and all the data needed for its assembly and production. And the assembly drawing shows the various parts of a machine in their proper position in relative to each other. Now, for the slide is on, you see the diagram, and I tag the figure 1.3 about assembly drawing. Now, the next to look at the part drawing. Part drawing, this is component or part drawing is a detailed drawing of a component to the facilities its production. Now, when we talk about the part drawing, it's the different drawings of various in details of various components of that machine or of that facilities. All the principles of orthographic projection and the techniques of graphic representation are followed to communicate the details in a path drawing. A path drawing with a production details is called production drawing or working drawing. Please take note. A part drawing with a production details is known as production drawing or part drawing. So if you go, you see slide 8, you see the assembly, the part list assembly drawing, how it is drawn. Please, the material will be sent to us. I will ask the admin to send it to us so that we'll go through it, and I want us to practice the drawing. Now let's quickly look at the application of engineering graphics. The application of engineering graphics, which we couldn't say much last week. One, mechanical. And now in mechanical, we talk of design of machine elements, CNC, machine tools, robotics. Now, when I mean CNC, I mean computer numerical control. Now, every machine that comes today, even up to late machine, they are all CNC machines. They are all CNC. Not more those days we use manual machines. Now, we talk about the automotive, the kinematics, hydraulics, steerings, and etc. Then the electrical we look at the circuit layouts. These are these are engineering drawing. Also panel design and control systems, these are engineering design. So, and in electronics we'll talk about the schematic diagrams of PCs or ICs, etc. Then in communication we talk about the communication network, the satellite transmission pictures, TV telecasting, filmation, but a few. Then when we look at the area of civil, we talk about the mapping, contour plotting, building drawings, structural designs. These are the areas of civil. Please, I want us to know, because in this program, in this course, someone will be producing a a building plan. So it's one of the mandatory things we must do. We're going to draw the electrical, the mechanical, and the building plan. And if time permits, we can bring out the structural drawing. In numbers 7, look at the architectural drawing, the architectural. Now, this is the town planning, interior decoration, multi-storied complex. This is architectural. And when we look at the aerospace, we talk about the design of spacecraft, flight simulation, lufting. These are some of the areas of application of engineering design. Now, engineering standards are code. Every drawing, every design, engineering standard drawings, we have standards and codes. So, because of time, I will not want to go much into that. Now, there are bodies that approve engineering drawing. Like in Nigeria, we have the current Council for the Regulation of Engineers in Nigeria. They certify drawings and certify engineers. Okay, you are free to do these things. Now, in the British, we have the British standard, or we have the ISO standard. So every nation has their own standard. So every building you are building, every construction you are constructing, it need to have an approval, an engineering drawing, and the engineering drawing must be approved by the regulatory bodies. Now, every engine in Nigeria, I said Koren, Council for the Regulation of Engineers in Nigeria, are in charge of the engineers in Nigeria. Now, what are the objectives of standardization? What are the objectives of standard? Number one of the objective is to make available the best practice to everyone, to give everyone. Now, you can remember some of us in Lagos, some areas in Nigeria, building collapses here and there. Now, until the engineers woke up, the Council for the Regulation of Engineers woke up, and other bodies woke up, then this they now started bringing up standard that must be followed before you can construct a building. And if you get to Lagos, there are so many tests you have to carry out if you want to construct a story building. You so many tests. The all the departments will have to come one after the other, carry out their test before they grant you an approval. Two, to provide interchangeability and compatibility between similarly functional products manufactured by different organizations. Three, to establish performance criteria for product, material, or systems. Four, to establish a common basis for testing the performance and characteristics of production material or systems. Five, to promote uniformity of practice among countries of the world. Six, to increase the efficiency of engineering effort. Example of standardization. One, we have the British Standard Institute. That's the bodies. We have the ISO, International Standard for International Organization for Standards. We have the SON, Standard Organization of Nigeria. Then we have the SAE, Society of Automotive Engineering. So these are some of the examples of the standard, the bodies that approves. Now we have in engineering drawing, there are principles that you have to follow. Now, like last week, we talked about the drawing sheet. So as part of our assignment, I want everyone today take note of this assignment. Please prepare a drawing sheet with the title block and border lines. Snap it and scan it and send it to my email. That will be our assignment for today. Prepare a drawing sheet with containing the title bar, the title block, and the border line. Design a drawing sheet or containing the border lines and title block, putting your names on it. Please make research. This need to be submitted latest by Friday, tomorrow, latest by Friday, 23:59 p.m. Latest by Friday. Let me have the drawing of engineering engineering drawing sheet with the title block and the border lines. Don't forget, I told you the border lines, they are make sure they have their own diagram below. So please make sure you follow the instructions. It's very, very important, and I'll take that not seriously. Then on the engine, drawing sheet, after titling it and the borderline, write the cap lock in capital letter. Let me use the word in capital letter A to Z. So lettering, let's do lettering today. A to Z. Just put all of them inside that drawing sheet. A to Z, the lettering. So please, I want to get them by tomorrow, 23:59 p.m. We have to get it 23:59 p.m. The assignment again is present a drawing sheet with the title block, border lines, and do the lettering A to Z in cap lock. So I will see you tomorrow, and from there we'll talk about other areas of engineering in which we will have to look into. So we will not. I would not like to cut this thing short. I don't know when the server man will take us, but I want us to do this. Now, let me quickly introduce you to projections before our time goes up. Now, in engineering drawing system or components, there are three dimensions, namely the length, the width, and the thickness. There are three dimensions when it comes to engineering drawing component. We have the length, the width, and the thickness. Now, drawings are prepared on a plain sheet, which are usually two-dimensional. So these are what we want to do. What we want to understand by projection, please take note and listen very well. Projection is defined as the representation of a three-dimensional object or a two-dimensional object. Projection is defined as the representation of a three-dimensional object or a two-dimensional plane. This can be achieved with either orthographic or isometric or oblique. Please, when we talk about projection drawing, it can be achieved either by orthographic, two, isometric, and three, by oblique projection. Now, we're going to establish the facts about these three as we go on in this class. The projection of any system of a part must clearly express all the three dimensions I just listed to you. The elements to consider while obtaining projections are: one, the object. While obtaining projection, what are the elements to consider? Please, let's take note of this. Might be it can come as a theoretical question in our exam. What are the elements? One, the object. You have to consider the object. Two, the plane of the projection. Two, the plane of the projection. Three, the point in space or point of sight. The point in space or point of sight. Four, the projector or rays of sight. The projector or rays of sight. So these are the four elements to consider while obtaining projection. Now let's quickly look at them. Orthographic projection. Orthographic projection is one in which the projector are parallel to each other and intersect the plane of projection at right angle to it. Now you can see that in my figure, in the figure 5.1. Orthographic projection is one in which the projectors are parallel to each other and intersect the plane of projection at right angle to it. That is as shown in the diagram below. That is my slide 27, there in slide 27. Now, this is obtained by viewing the object from a point in space and tracing in correct sequence the point of intersection between the projector and the plane on to which this object is projected. So you can see that there as orthographic projection in my slides like 28. You can see it there. Orthographic projection mainly uses the horizontal and vertical plane. The orthographic projection uses the horizontal and vertical plane. Now let's look at the advantages of orthographic projection. The advantages: number one, it presents a true picture of each face. Circle remains at circle. Now it projects a true projection, a true picture of each face. But for the circle, circles remains as circles, but other component is project the true picture. Number two, there is no limit to the number of views that can be drawn. There is no limit to the number of views that can be drawn. Number three, the view drawn are related to each other in position. The view drawn are related to each other in position. So you can see that one from the diagram I just showed on this on the previous slide. Now the next one we're looking at is the first angle orthographic projection. First angle orthographic projection, and we must have had this and we'll have seen this in mathematics. Now the first angle orthographic projection is in the first quadrant. Now, in mathematics, we have the first, second, third, and fourth quadrant. I know we still remember our mathematics. Now, when we talk about the first angle projection, we are talking that we imagine the object to be in the first quadrant. So the view from the front of the object is obtained by looking at the object from the side view of the quadrant and tracing in